Okay, this is the beginning of section 9.2, looking at graphs of quadratics. And what I have graphed here is the graph of y equals x squared. And over here on the left, you're going to see all the graphs that we're going to be looking at. I wanted to figure out what happens to this graph when I add 3 to it or subtract 2, add 3 inside the parentheses or subtract a number inside the parentheses. What happens when I multiply by a fraction or a bigger number or a negative number? First of all, let's look at the equation y equals x squared plus 3. We're going to look at the table of values that goes with this graph. And you can see I also have the table for my f function as well, y equals x squared, and this is y equals x squared plus 3. The numbers here on the right in the g of x column are always 3 more than the numbers on the f of x column. So let's look at what this means graphically. First of all, I'm going to show some of these points on my f function. And then I'm going to plot these points on my g function. And let's look at one of these points on this f function. Let's look at the vertex, the point 0, 0. You can see that on my g function, the vertex is going to be the point 0, 3. Every point on this g graph is 3 more than what's on the f graph. And that makes sense because my function is x squared plus 3. Okay, now we're going to be looking at this next graph of y equals x squared minus 2. And you can see in my table that the numbers here are 2 less than the numbers in the f of x table. And plotting the points for my h function, I have these blue dots, and there is my graph. All the points on this blue line are 2 units below my original graph. The number that's added after this x squared, the plus 3 or the minus 2, is going to shift my graph up or down. Now we're going to look at this graph P, and this is x plus 3 squared. And we can see here what happens to the graph is that it is shifted left. To me, it's just sort of opposite of what I would expect. On the second function up here, my g function, when I added 3 out over here to the end, it shifted the 3 up in a positive direction. So it would seem like this would shift it to the right, but it's just the opposite. It shifts it to the left. And a similar thing here with my q function. This minus 4 in the parentheses is going to be shifting my graph to the right. Now let's look at the graph of y equals 1/2 x squared. What I want you to see here is that the graph is wider. It's because these y values are only going up half as fast. So my graph's wider. The graph of y equals 2x squared, this green graph, is skinnier than my original function, or more narrow than my original function, because my graph is going up twice as fast. Now, I do need to make a point here that just because you have a fraction, like y equals 1/2 x squared, doesn't mean that your graph is always going to be wider. What if I had the graph of, let's say, y equals 3/2 x squared? Well, that graph is skinnier. And the reason why is because 3/2 is an improper fraction. It's actually more than 1. So you can't just look at the coefficient and say, oh, it's a fraction, it's going to be wider. You have to see if that fraction is actually more than 1 or less than 1. Now there's the graph of y equals negative x squared, and what we can see there is the graph is just opening down instead of up, it's reflected across the x-axis.